anglerfish. It lives in near total darkness, somewhere between 200 and 2,000 meters below the surface, where pressure is immense and food is scarce. The female is the one most people picture: a grotesque, wide-mouthed fish with a glowing lure dangling from a spine on her forehead. That lure is a living light. It contains colonies of bioluminescent bacteria that glow continuously, mimicking the faint shimmer of small prey to draw curious animals close. When something approaches, the anglerfish strikes in milliseconds, swallowing creatures up to twice her own size, her stomach stretching to accommodate them. Her teeth angle inward, making escape almost impossible once caught. The male, by contrast, is tiny, barely a few centimeters long. He has no lure, no hunting ability, and no way to feed himself independently. His only purpose is to find a female. When he does, he bites into her side and never lets go. Over days, his body physically fuses with hers. His eyes dissolve. His organs merge into her bloodstream. What remains is little more than a sperm-producing attachment. A single female can carry up to 6 males fused to her body at once. Goblin shark. It has been swimming in the deep ocean for roughly 125 million years and has changed very little since. Its most distinctive feature is a long, flat snout that extends well beyond its jaw, giving it a face unlike any other shark alive. That snout is covered in sensors called ampullae of Lorenzini, which detect the faint electrical fields produced by the muscle movement of nearby prey. The goblin shark moves slowly and is poorly built for speed, so it uses a different approach. Once prey is within range, its jaw launches forward independently of the rest of its skull, a catapult mechanism powered by elastic ligaments that releases in 322 milliseconds. The jaw extends several inches outward, creating suction as it opens, pulling prey in before it has any chance to react. Most humans will never see one. It lives along deep continental slopes between 270 and 1,300 meters down. And encounters are so rare that much of its biology is still pieced together from specimens caught accidentally in deep-sea nets. Giant squid. For centuries, sailors described a tentacled monster large enough to drag ships beneath the sea. The giant squid is the creature behind that legend, and the reality is nearly as dramatic as the myth. It grows up to 13 meters long, making it one of the largest invertebrates on Earth. Its eyes are the largest of any living animal, up to 30 centimeters in diameter, roughly the size of a dinner plate. Scientists believe those enormous eyes evolved specifically to detect the distant, bioluminescent glow that sperm whales produce as they move through plankton, giving the squid just enough warning to attempt an escape. Despite its size, the giant squid was so elusive that the first confirmed photographs of a living adult in the wild weren't taken until 2004. Its 2 long tentacles are lined with suckers rimmed with sharp, serrated rings that cut into prey on contact. Sperm whales are their primary predators, and the circular scars from squid suckers found on whale skin suggest battles far below the surface that no human has ever witnessed. Frilled shark. It looks less like a shark and more like something that belongs in a prehistoric sea. Its body is long and eel-like. Its 6 pairs of gills are frilled with reddish tissue along their edges, and its wide, flattened head holds a jaw lined with 300 trident-shaped teeth arranged in 25 rows. Those teeth point backward, which prevents prey from wriggling free once caught. The frilled shark has been around for at least 80 million years and is often called a living fossil, not because it is primitive, but because it has remained effective enough that evolution had little reason to change it. It is rarely observed alive, and most of what scientists know about it comes from accidentally caught specimens. When fisherman David Guillot caught one off the coast of Japan in 2015, his first reaction was that the head looked like something from a horror film. The frilled shark hunts by coiling its body and lunging forward, striking with speed that contradicts its otherwise sluggish appearance. Vampire squid. It is neither a squid nor an octopus. It belongs to its own distinct order, Vampiroteuthis infernalis, which translates directly to vampire squid from hell. And it is the sole surviving member of a lineage that split from both squid and octopuses hundreds of millions of years ago. It lives between 600 and 900 meters down, in what oceanographers call the oxygen minimum zone, where dissolved oxygen drops to levels that most marine life cannot tolerate. The vampire squid thrives there, surviving on just 3% of the oxygen found at the surface. Its 8 arms are connected by a dark, webbed cloak of skin, giving it the appearance of a creature wrapped in a cape. When threatened, it inverts that cloak over its body, revealing rows of fleshy spines and turning itself inside out. It also releases a cloud of bioluminescent mucus glowing particles that confuse predators in the dark while the squid retreats. Unlike its relatives, it does not hunt. It feeds on drifting marine snow, the constant downward rain of dead organisms, feces, and organic debris that falls from the layers above. Giant isopod. It is related to the common pill bug found in garden soil, and it looks exactly like one, except it can grow up to half a meter long and weighs several kilograms. The giant isopod lives on the seafloor at depths between 500 and 7,000 feet, crawling across the sediment on 7 pairs of legs. Its body is armored in overlapping segments, and when threatened, it rolls into a tight ball just like its terrestrial cousins. It is a scavenger, drawn primarily to the carcasses of large animals that sink to the bottom. Whales, sharks, large fish. These meals are rare and unpredictable, so the giant isopod has evolved an extraordinary ability to survive without food. One specimen held in captivity at an aquarium in Japan went without eating for 5 years and 4 months, before dying not of starvation, but of unknown causes. Its large size is a product of a phenomenon called deep-sea gigantism, a pattern seen across many species in the deep ocean where reduced metabolism, cold temperatures, and increased pressure seem to remove the upper limits on how large an animal can grow. Barreleye fish. It is small, transparent from the head up, and almost completely stationary most of the time, hovering motionless in the twilight zone between 600 and 800 meters down. What makes it remarkable is immediately visible. 2 bright green cylindrical eyes sit inside a fluid-filled, dome-shaped head made entirely of transparent tissue. Those eyes can rotate. They point upward by default, scanning the faint silhouettes of animals moving in the dim water above. When the fish locates prey, the eyes rotate forward. For years, scientists studying preserved specimens were confused because the transparent dome collapses when removed from the water, and what they thought were its eyes were actually its nostrils. The actual eyes were inside the dome all along. It was only in 2004, when researchers filmed a live specimen using a remotely operated vehicle, that the full structure became clear. The barreleye feeds primarily on small jellyfish and siphonophores, carefully stealing food from the stinging tentacles without triggering a sting. Fangtooth fish. It is only about 15 centimeters long, smaller than a human hand, but proportionally, it has the largest teeth of any fish in the ocean. Its fangs are so long they cannot fit inside a closed mouth, and 2 of the lower teeth slide into sheaths in the upper jaw to prevent the fish from impaling its own brain when it bites down. The fangtooth lives in mesopelagic and bathypelagic depths, anywhere from 200 to 5,000 meters below the surface. Its appearance is severe: a dark, compressed body, enormous eyes adapted for the faintest traces of light, and a mouth that seems far too large for an animal its size. Despite its alarming design, very little is known about how it hunts, how it reproduces, or how long it lives. Scientists rarely encounter live specimens, and much of the research on this species comes from animals that surfaced already dead or were caught as accidental bycatch. Juveniles look so different from adults with long spines and a pale, transparent body that they were once classified as an entirely separate species before the connection was made.